Hello class, I wanted to put together a short video tonight with respect to or in regards to problem set 9. I realize we're going to do some bitwise operators, bitwise operations. These things, we haven't done a lot of these yet, and they're actually really important, but it may seem a little bit new to you. So I'm gonna run through one cut of this video. I'm not gonna spend a whole lot of time making it pretty, but I want to introduce the topic a little bit to give you some help and provide some context. Okay, remember everything within the computer is stored in binary. Okay, so we have this integer class that you've created for part of your homework, and we're gonna look at this. This class has this attribute v. Okay. And v is an integer, right? It's stored as an integer, and in the instructions it said assume it's a 32-bit integer. So what does that mean? It means this value, okay, assume this thing is stored in 32 bits. And I'm not going to write out 32 places here, but imagine if I did 32 places. We have this integer, and it's this is what it looks like depending on the value, right? We have a bunch of ones and zeros. And we're asking you in this problem to this function here. It's oh, I've got it here. I forget what it's called exactly. It is called get bit values. We're asking you to get take a look at a particular index, if you will, of this integer. So let's just make sure we understand what the problem's asking. Let's say the value for v is 7. We're going to do some smaller numbers here. So if this was 32 bits, we'd have a whole bunch of zeros, and then the 7 in binary is 111. So I'm just going to write it as an 8-bit number. Of course, again, we've got a whole bunch of zeros to the left here. But here's what 7 looks like. And then we're going to give this index value, and we're supposed to return true if it's a 1 or 0 if it's a false. So what's that saying is it's saying this is the first bit, this is the second bit, this is the third bit, this is the fourth bit, this is the fifth bit, sixth, seventh, and eighth, all the way to 32. And we're asking, okay, if we give this function, this method, if we pass it 3 is the argument, we're trying to determine if this particular bit is a 1 or 0. Okay, and to do this, you're gonna use there's several ways to do it, but we're gonna use some bitwise operations. So let me just introduce a couple of these. They look very similar to our logical operators, and if you remember our logical operators, we have and, or, not. There's actually more than that, but those are the basic ones. Well, these same things, this is logical. This is, when I say logical, this is what we would use in a while statement, or we might use in an if statement, right? Well, there's also this bitwise. And these look like, oh, let's see, they have, instead of using and, or, and not, they actually are an ampersand, which I'm not terribly great at. Let's see, it should look something like what? Like that. The or looks like this. It's a pipe. Okay. And then we have some shifts, and you'll see this in your instructions, some shifts left, shift left, shift right. The shift left, I think it points to the left. That's right. Shift right points to the right. Let's just look at a couple of these things, what they do. So if we let's take this, let's create our own some different values here. Let's do x equals 10 and y equals 14. The first thing I'm going to do, and these are small numbers, we're gonna look at these in their binary formats. 10 is 1010 in binary. What is 14? Well, let's just come up with it really quick. Remember, in binary. This is the ones place, twos place, fours place, eights place, 16 place. Or we can think of it as 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, right? 2 to the 4. Okay, well, how many? We want to go to 14. So how many 8s do I need in 14? Well, I need an 8. I need a 4, that's 12. I need a 2, that's 14. So 14 looks like that. Now, if I'm going to do an AND operation, this is very similar to our logical AND. We need both elements to be true in order for the AND to be true. Okay, what is true and false in binary? Well, 1 is true and 0 is false. So as I look down here and I look at 0 and 0, that's false and false. If I apply the AND to that, the AND operation of that's going to produce a 0. If I look at 1 and 1, 1 and 1, they're both 1s, that's going to be true. That's going to be a 1. Okay, 0 and 1. Again, on AND. No, it's going to be a 0, because in order for an AND to be a 1, they both have to be 1. 1 and 1 here, this is a 1. So if I were to do something like this, and I was to say Z equals X and Y, the result of Z would be that. That's the bitwise AND operation. We can do a truth table if that helps you even more. And this is the way we do a truth table. It looks something like this. We have, we could have, in this case, just 2 bits. So we could do something like this. Bit 1, bit 2, result. Okay. And we can have 0, all possible combinations here. Looks like this. And this is the AND. Well, this is a 0, this is a 0, this is a 0, this is a 1. We did the same for an OR. Bit 1, bit 2, result. Okay, OR is a little bit different. Here's all of our possible combinations. Remember, the way an OR works, a logical OR, a bitwise OR works the same way. This is an OR. If either value is a 1, then the whole thing, the result, the outcome is a 1. So a 0, 0, the result's a 0, 1, 1, 1. This is an AND. Okay. Hope that kind of helps. That's what we're doing when we're looking at this thing. So now if we go back to our example here, if I was to redefine Z equals X or Y, what would that look like? Well, here's my OR. 0 and 0, that's going to be a 0. 1 and 1, that's going to be a 1. 0 and 1, that's going to be a 1. And 1 and 1, that's going to be a 1. So the answer for Z now, X or Y, is going to be that, 1, 1, 1, 0. Okay. Now, if we did some shift operations, what that's essentially going to do, I'm going to let you work that out as an exercise. But what I want you to do is take a known value, something that you know the binary value of. So like we've done here, we've got 14, for instance. We know 14 is this. So what I'd like you to do is do something like this. Y, oops, sorry about that. Y equals 14. And then do something like this. Z equals Y. Shift the bits left. Just shift the bits left 1. Do something like A equals Y. And shift the bits right by 2. And see what happens. Essentially what you're doing, oops. Let me do that. Essentially what you're doing is you're taking this 14 and you're either shifting bits right or you're shifting bits left. And when you shift, if you shift bits left or right, what's happening is you're filling in with empty zeros. Okay, so what you need to do is shift the bits left one and see if you can guess what the answer might be. Okay, shift the bits right 1 or 2 or 3 and see if you can predict what the answer is going to be, and then test yourself and print A or print Z. You can do those print operations to see what the answers are. Okay, there's a lot of tutorials online. I hope this helps. I don't want to give you too much more because I really want you to work through this. So you're going to have to figure out, going back to this initial problem here, you're going to have this integer. You're going to have to figure out if a particular bit is a 1 or 0 in there. And there's some ways to do it. I'll give you a small little hint. There's these things called bit masks you're going to use. And you're going to use, you can do this by applying an AND operation. You can do this by shifting bits a certain number of positions left or right. Think about that. If we're trying to determine this, what could we do? Well, we could shift it all the way to the right, and then just a certain number of shift to the right, and then we can just check the rightmost bit or the least significant bit. Okay, that's enough on that. I want you to work through it and figure it out. It's kind of a fun exercise. Hopefully this was helpful, not too confusing. Again, after you sufficiently worn yourself out working through this, if you're still stuck, give me a holler and we'll talk through it. Wish you the best.